Have you ever wondered how gold is made? Well, the answer to that question takes us on a journey that's quite literally out of this world. You see, gold, like all heavy elements, has a cosmic origin. It's not crafted in some terrestrial forge or factory, but rather in the chaotic death throes of a massive star, a process known as supernova nucleosynthesis. But what does that mean exactly? Well, let's break it down. A supernova is the explosive death of a star, a cosmic event so powerful that it briefly outshines entire galaxies. As the star collapses under its own gravity, it triggers a shockwave that causes the outer layers of the star to explode, scattering its contents across the universe. But the real magic happens in the heart of the dying star. Under the intense heat and pressure, atoms are squeezed together, creating heavier elements through a process called nucleosynthesis. Most of the elements we know, up to and including iron, are formed in the normal life cycle of stars. But to create something heavier than iron, like gold, you need the extreme conditions found only in a supernova. In this cosmic crucible, protons and neutrons are forced together in various combinations, forming new atomic nuclei, and among these are the nuclei of gold atoms. These gold atoms, newly formed and incredibly hot, are then blasted out into space by the force of the supernova. Over billions of years, these atoms journey through the cosmos, eventually becoming part of interstellar clouds of gas and dust. And when these clouds collapse under their own gravity to form new stars and planets, the gold atoms are incorporated into the mix. So the next time you look at a piece of gold, remember its incredible journey. It was forged in the heart of a dying star, traveled across the cosmos, and eventually found its way onto our planet. So, in essence, every piece of gold you've ever seen was born in the heart of a dying star. But how does this celestial gold end up on our planet? Well, it's quite a cosmic journey. The remnants of supernovae, those stellar explosions, are scattered across the universe, containing an array of elements, including gold. These remnants eventually form nebulae, vast clouds of dust and gas. These nebulae serve as the birthplaces of new stars and planetary systems. It's a cycle of cosmic life and death, with the end of one star leading to the birth of others. Now let's bring it closer to home. Our very own solar system, including Earth, was formed from such a nebula around 4.6 billion years ago. That's right, our planet, the ground we walk on, the air we breathe, it all started in a nebula billions of years ago. But where does gold fit into all this? Well, gold, like other heavy elements, was integrated into the Earth's structure during its formation. As the nebula contracted and the proto-Earth began to take shape, heavy elements such as gold sunk towards the planet's core. However, a portion of these elements remained in the crust, trapped within the rocky material that makes up our planet's surface. When our planet was young, it was a hotbed of geological activity. Volcanic eruptions and shifting tectonic plates brought some of this gold back to the surface, where it became concentrated in veins of quartz and other minerals. Over time, erosion and weathering released these gold particles into rivers and streams, creating the placer deposits that sparked gold rushes throughout history. So, when you hold a piece of gold, you're not just holding a precious metal, you're holding a piece of the cosmos, a fragment of a star that exploded billions of years ago. You're holding a testament to the incredible journey that all matter in the universe undergoes, from star to nebula to planet. So the gold we mine today has been a part of our planet since its very beginning. Now that we know where gold comes from, how do we get it? Well, it's not as simple as picking up a shiny nugget off the ground. We mine it. Mining is the process of extracting valuable minerals or other geological materials from the earth. So, how does this work for gold? There are two main methods, placer mining and hard rock mining. Placer mining is used for secondary deposits like those found in rivers and streams. Picture a prospector from the Old West panning for gold in a river. That's placer mining. The gold is mixed with sand and gravel, and it's separated by gravity. It's a simple process, but it's also labor-intensive and not always efficient. Now let's talk about hard rock mining. This is how we get to the primary gold deposits, the ones still tucked away in the Earth's crust. These mines can be deep, and the process is more complex. It involves drilling and blasting to extract the ore, then crushing it to release the gold. However, mining doesn't come without its challenges. It's a risky business, with hazards ranging from cave-ins and floods to hazardous materials. Additionally, it can have significant environmental impacts, including deforestation and water pollution. Once we've got the gold, it's time to refine it. This is where the raw gold ore is purified into high-quality gold bars. The ore is smelted, a process that heats it to high temperatures to separate the gold from other elements. Then it's poured into molds and cooled to form gold bars. These bars are then ready to be sold or used to make jewelry or other gold products. This process, from start to finish, takes a lot of hard work and expertise. But it's worth it, because at the end of the day, we're left with one of the most valuable and coveted materials on the planet. And that's how the gold in a supernova billions of years ago ends up in a jewelry store near you. But why are we so fascinated with gold? Well, it's not just because it's shiny. Gold has a unique combination of properties that make it incredibly valuable. Its beauty is undeniable. With a lustrous yellow glow that's been captivating humans for centuries, it's rare, which adds to its allure. But it's not just about looks and scarcity. Gold is also malleable, meaning it can be shaped into intricate designs without breaking. This has made it a preferred material for artisans and craftsmen throughout history. And let's not forget its resistance to tarnish. Unlike many other metals, gold doesn't rust or corrode, meaning it can endure through the ages, just like the civilizations that have prized it. These properties have made gold a symbol of wealth and power, a token of human achievement and desire. So, the next time you see a piece of gold, remember the incredible journey it has made from the heart of a dying star to your hands.